We're going to be converting from decimal to binary. The number that we are going to be converting is 123,456. However, this process would be the same for any number. So we are going to take this number 123,456, and then what we are going to do is we are going to plug into our calculator 2 raised to the power of something. Now this something has to be a little bit higher than the current value that we have written down, and that value is 2 to the 17th. 2 to the 17th is 131,072. So we're going to take one less exponent than that, which so we'll get 2 to the 16th. And so that means we are going to set this equal to 2 to the 16th. That's what we're going to start from. And then we are going to go down here. We're going to go 2 to the 16, 2 to the 15, 2 to the 14th, 2 to the 13th, 2 to the 12, 11, and so on and so forth until we get to 2 to the 0th. Now what we're going to do is we're going to take this 2 to the 16th, and then we're also going to take our initial value, which is 123,456. We take 123,456, and then we subtract 2 to the 16th from it. If our number is positive, that means that this value is less than our current value, and we have a 1 here, 1 for truth. Now we're going to do the same thing for this 15, but remember, we're going to subtract every single one of these, if it's a 1, continuously down. So we have this initial 123,456, but because we have a 1 inside of here, we have 2 to the 16 being subtracted, and now we're going to do the same thing, but this 15. So plugging this into our calculator, because that was pretty long, we're going to have the first number minus 2 to the 16 minus 2 raised to the 15th. And since this number is even, we are going to have a 1 here. Now we're going to do the same thing with the 14. So we're going to have our initial number minus 2 to the 16 minus 2 to the 15 minus 2 to the 14th. This is a positive number again, so we are going to have a 1 here. We're going to do the same thing. The initial number minus 2 to the 16th minus 2 to the 15th minus 2 to the 14th minus 2 to the 13th. And it is a positive number, so we're going to have another 1. Now, our number is 576 after we've done all of these. So after these 4 operations right here, this number is 576. Now, that's a pretty small number considering all of these 2 to the powers that we have left. So what we can do is test all of these values, but if it gets a 0, it's not going to be added into the subtraction of this. And just because it's a little vague, we're going to show this on paper. So we have 1, 2, 3, 4, 5, 6 minus 2 to the 16th because it's a valid number, minus 2 to the 15th, valid, minus 2 to the 14th, minus 2 to the 13th. These are all valid, and that's how we would get this 576. Now, if we subtract this 2 to the 12, we're going to get a negative number. So we cannot subtract this 2 to the 12. Let's try 2, I put 12 right here, that should be a 2 to the 12. Let's try 2 to the 11th power. Remember, we're not including 2 to the 12th. Well, this is also a negative number, so this is not going to work. Let's try 2 to the 10th. So we're putting this in here, and remember, we are skipping 2 to the 12th and 2 to the 11th. 2 to the 10 is also no good. It's going to give us a negative number. So we're going to try 2 to the 9th, and we're going from all of these values up here, skipping 2 to the 12th, 2 to the 11th, and 2 to the 10. That's super important. You don't want to include those. And if we plug in a 2 to the 9th, we're going to get an even number, and this even number is going to be 64 right here. So this checks out. That means this is a 0, this is a 0, this is a 0, but this is going to be a 1. So let's keep going down the line. 2 to the 8 is going to be too big. If we subtract this, we are going to get a negative 192. So 2 to the 8 is not going to be in here, and we can represent this as a 0. So we'll skip 2 to the 8, and we'll try 2 to the 7 in our calculator. We're still going to get a negative number. We're going to get a negative 64, so 2 to the 7 is out. Now we will try 2 to the 6, and 2 to the 6 is 0. Well, that is a positive number, so that checks out. So we're going to have a 1 here. And once we've hit 0, we have nothing else left to do. So that means the rest of these are just going to be zeros. So we'll have a 0 here, 0 here, 0 here, 0 here, 0 here, 0 here, and lastly a 0 here. So our total answer, this value, 123,456 in binary form, is going to be 1, 1, 1, 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0. And that is how you would go about solving for this long example. I did just realize though, I made a mistake. This 2 to the 7th we wrote down as a 0 here, so this should be x'd out. So this should be 0 right here, and this should be 1, because that is what that is. So all we're going to do in our answer is switch these two about. We are going to have a 0 and a 1 here, and that's because of this right here. So if it's an x'd out, that means we got a negative number, and if it is a check mark, that means we're still in our range, and that is part of our answer. And that is how you would convert from decimal to binary.